Do renewable sources of electrical power rely on other sources? Let's find out. Hi, I'm Kevin. There are lots of different ways to provide electrical power to the grid. Here in Alberta, we have, I think, a little bit of almost everything. We've got, still have a bit of coal, got lots of natural gas-fired equipment, hydroelectric, wind, solar. We don't have any tidal, no oceans, and we don't have any nuclear yet. We got a bit of everything. Some places only have one source, such as British Columbia only has hydroelectric supplying their grid. Now, when we think about classifying sources of electrical power, we usually think renewable and non-renewable. But we're going to do this a little differently. We're going to look at this from the perspective of supply and demand. And since supply must match demand, we're going to look at each of the, or some of the different electrical power sources we have here in Alberta, and we'll look at how it fits into the equation supply equals demand. Then we can look at how each of these different sources work well together. Let's dive in. Okay, so for starters, I have arbitrarily made three classifications for electrical power supply. I have defined what we'll call a base supply, opportunistic, and on-call. So now I'll describe them by through example. So a base supply is something that is big, and they take a huge bite out of the demand, but it doesn't really change production. But they don't like to change in rates very much. So something like a nuclear power plant is a really good base supply. Another one is a coal-fired power plant. That's also a good example of a base supply. Okay, now let's go on to this side here, opportunistic. What do I mean by opportunistic? Well, it's kind of like you get what you get and you don't get upset. One of my mother's favorite sayings. So something that depends on something else. And one really good example is solar. So we'll put solar down here because it's a good example of an opportunistic supply. And so is wind. If it's not wind, if the wind isn't blowing, you don't get power. The sun isn't shining, you don't get power. Okay, on call. These are the things that we can think about as a backup. And this helps out. This is required to ensure that supply matches demand. And here's the simplest example, just a good old-fashioned gas-fired generator. If you need power, turn it on. If you need more power, it runs a little harder. So this is a really good example for what I will call an on-call supply. So these are the three basic classifications. A base supply that makes lots at a steady rate, opportunistic, which makes power, but it depends on something else, and on-call, we have control over, and we use this to ensure that supply matches demand. Let's fill in the blanks for a few more of these. One of the largest suppliers of power in Alberta is combined cycle gas turbine, this little guy here. So a combined cycle gas turbine takes natural gas, runs it through a combustion gas turbine, makes a bunch of power with that, and the hot exhaust is used to make some steam, and we get even more power through a steam turbine. You can adjust the flow rate or the capacity of these plants, but they're big and they're complicated, and they don't change rates very quickly. So I'm going to put it maybe about halfway. It's kind of base supply, kind of on call. You can adjust them a bit, but you can't play with them too much. Okay, now in contrast, the simple cycle gas turbine, which I've represented by this little picture, that is just essentially a jet engine. And this is one of the cheapest ways to generate power from natural gas. You can turn it on quickly, you put gas through it, you burn it, it creates power, and you send that to the grid. They're quick to turn on, and you can adjust the capacity on these. So that on-call supply I'll put right about here. It's right at the very top. This is on-call. We can adjust this one really well. The next on-call supplier is this one, which may catch you by surprise, a large-scale hydroelectric dam. Now, it's really big, so you'd think, oh, it's a base supply, but no, you can adjust these. And because we can adjust these, we're going to consider this to be on call. And this is predominantly what British Columbia uses on their power grid, large-scale hydroelectric. Now, on the other side, we have small-scale hydroelectric. And these are kind of interesting because the generating capacity depends on the total flow rate that you have in the river that you're backing up. So it's lower in the winter, it's higher in the spring. So you got some base capacity that you can always rely on. That's the winter flow rate. And it's kind of opportunistic because the generating capacity adjusts or changes, but we can adjust it on an hourly basis a little bit. So this is interesting. So I'm going to put this one kind of right smack in the middle because it fits almost everything, but it's more on the opportunistic side. We're going to put it right there. Now we have this cogeneration or combined heat and power. This is where power generation depends on the heat needed for some other process. And a good example of cogeneration is heat needed for, say, a greenhouse. You use an engine to drive a generator, and the waste heat from the engine keeps the greenhouse warm. And the amount of power that you make solely depends on what the greenhouse needs for power. And that goes way down here. It's opportunistic, but it's also a bit of a base supply because we will have lots of these. And we've got many of these in Alberta, and not all of them will turn off at the same time. So we can almost think of this as a base supply. Finally, we've got a battery. And this is kind of an interesting one because at first glance, you would think this is an on-call supply because you can turn on the battery and dump power to the grid, but we also have to charge it up, and it also has a limited supply. So it actually belongs somewhere in the middle here because although you can turn it on when needed, it's got traits of being on call. It has a limited supply and you can only use it if it's available or it's charged up. Therefore, it must also be considered opportunistic. In summary, we need on-call power to ensure that our power grid is stable. On-call power is the most important category for power generation. Now, if we have large-scale hydroelectric, then we are fine. We don't need anything else. And in fact, why would we spend money on something like solar or wind when we need to build a large hydroelectric facility that has enough capacity to meet our peak demand? That'd be a waste of money. But here in Alberta, we still consume natural gas to produce the majority of our electricity. This means we need to use more and more renewable sources like wind and solar to reduce the consumption of natural gas in our power plants. But that also means we need to invest in on-call sources of power like simple cycle gas turbines or simple boilers and steam turbines. And this is needed to keep our lights on when the wind isn't blowing and the sun isn't shining. Take care. Bye-bye.